For this video, I'd like to discuss the concept of imaginary numbers. And these numbers arose out of the idea of taking a square root of -1. And before we try and deal with this square root of -1, let's first think about what it means to take a square root of just a normal number. So we can look at the square root of 25, for example. So this is asking what number multiplied by itself gives you 25. Or we could say x squared gives you 25. What is x? And we know that 5 times 5 would give you 25. So the square root of 25 would be 5. And similarly, we can apply that idea to the square root of -1. So we want to think what number multiplied by itself gives you -1. And we can try numbers. We can try 1 and 1, but it's pretty obvious that won't work because we'll get a +1. And we can also try -1 and -1, but a negative times a negative is always positive, so we get +1. And you might be tempted to do -1 times 1, but that would essentially violate the idea of square roots. They have to be the same number multiplied together. So that scenario wouldn't work for us. So there's no answer that we have with just our normal numbers. Or there's no answer with the real numbers. And so what mathematicians had to do was essentially to create a symbol to represent this number. And the symbol they chose for this was the letter I. And they were named these imaginary numbers. Though I do want to mention that the naming of these was actually done in a derogatory sense. So you may recall the mathematician Rene Descartes. He's famous for saying, "I think, therefore I am," but he's also a fantastic mathematician. He's the one who invented the coordinate plane, the XY plane. But he named these things imaginary numbers, and he did so in a derogatory sense. And essentially what I mean by that is that he did not like these numbers. He thought they were either nonsensical or fictitious, but he knew they had important uses because they worked in the solution of cubic equations, but nobody really understood why they worked, and they do kind of seem like these nonsensical numbers. So at the time, this was probably around 1640 or so, these things were not very well liked. But we have to keep in mind that if we go back in time far enough, even something like a negative number was seen as nonsensical, because people used to argue that you can't have a negative amount of apples or something like that. But now we know that if we talk about going backwards, that's in the negative direction. So negative numbers have a usage, and it's the same kind of evolution with these imaginary numbers. At first, they didn't seem to have much practical use, but over time, we've discovered that they're actually incredibly useful. And the way that I think about these numbers is as rotational numbers. And there are many reasons for that, but the main one is that a lot of times when you see a system in nature that's rotating, it's almost always easier to model it using these imaginary numbers rather than the real numbers. And you can imagine there are many things in nature that are rotating, so these things are pretty useful. So be careful being caught up on this word imaginary. They are just as real as the normal numbers. It's just a word that we give to them. Because it's not like the number 1 or the number 2 is ever found in nature, but those concepts exist in nature. And it's the same thing with imaginary numbers.